So, what did we do yesterday? I introduced you to the concept of getting a new parent function like this and going, geez, I haven't memorized it yet. How can I do it? You make an XY chart. And what would be good numbers to put in here? Like -2, -1, 0, 1, and 2. And that's 5 points. If you can't tell where a curve is going after 5 dots, then you're pretty bad at this. These are 3 of them, which I get. I'm not sure where it goes yet, but when you do the 4th and the 5th one, you'll be like, oh, well, obviously it must be going like that. You get 5 dots, you'll be able to figure out what it is. That one's x to the 3rd, and it's got arrows on each end. Does that make sense to you? Now, the domain and the range part was harder. You just look at this and you ask yourself, for domain, you're asking yourself, how far left and then how far right does this thing go? If you extended it out, this would go forever to the left, which is where negative infinity lives. As far as x's go, because that's what domain is, this thing would keep going further and further to the left if you let it go, and this would keep going further and further to the right. Yes, it's going up, but it's also going to the right. So this one keeps going in both directions, and this, if you don't write the double circle thing, if you just want to write negative INF, I will accept that for negative infinity, and this is INF for infinity. So this one's domain left, negative infinity. Again, I'm doing a circles right next to each other thing, which is the symbol for infinity. Or you can totally just write INF like that. And then I put parentheses around things that I can never touch. Are you with me so far? The domain goes all the way to the left, like as far as you can go, and then this also goes all the way to the right as far as you can go. Range is down and then up. The reason I make such a big deal about that is a lot of people do it backwards. Your numbers have to be in order from small to big. So down first and then up. How far down will this thing go? All the way down, which is at negative infinity. You can write INF if you want. Comma, how far up will it go? Well, it'll go all the way up, which is where positive infinity lives. You can say INF if you'd rather. And those are parentheses, because you can't get to infinity. All right, now here's a weirder one. I'm going to on purpose move it and flip it. Let's say you had the square root, but it was backwards. Yes, it's stopping right at the origin, which is 0, 0. My question is, what's the domain? How far left and how far right? What's the range? How far down to how far up? See if you can do that. I'm going to pause for a second. All right. This is the part where cell phones need to go back away because I was gone for a bit, but now I'm back. And here we go. The domain is how far left to how far right. I want to just see how good a random person is. It gives me a better idea than calling on somebody who raises their hand because they obviously know how to do it. This is going to be the 6th row and the first person. Nico, that's you. Can you tell me what you had for the left and the right? You're right on that. It goes all the way to negative infinity on the left side. How about on the right side? Perfect. Then the range. This is row 1, last person. Lowest it went to 0, correct. What's the highest it goes? Do you get how it's still rising? It's still getting higher and higher and higher and higher. Infinity. Should have been 0 to infinity. Raise your hand if you had that one right. Okay. What?
Brackets.
Oh, good point. Yes, it does touch 0. Bracket there, and it touches 0 here, so brackets there. Very good catch. All right. Feel like you're getting better at this if you're starting to correct me. That's a really good sign. Okay, let's try one more. So, let's say I have a parabola. You guys all know the parabola, but let's say I shift it down a bunch compared to normal. That parabola is going down, let's say, 5 spots. So that would be 0, 5 right here. It's only fair to tell you how far I went down. Okay. So my question is, What's the domain, which is left and right? And what's the range, which is how low to how high, or down to up? Remember, you got to imagine this thing keeps going, like forever. And was it moving up? Yeah, but was it also moving left? Yes. It's going left and up. You can do both at the same time. If it was only going up straight, it wouldn't be a function anymore. It wouldn't pass a vertical line test. If it was really straight up and down, it stopped going left, then it's not a function. Okay, so this thing is going to the left constantly, and it's going to the right constantly. So, what do you think the domain is? Random person, row 2, fifth person, 1, 2, 3, 4. I guess Cyril, that makes it you. Domain?
Negative infinity.
Yup.
And plus infinity.
You got it. Nice job. Negative infinity and infinity. And the range. This is row 4. And last person, Quinn. What's the lowest it goes?
-5.
You got it. And, oh, that should have been a negative down there. Good call. You even corrected it. Even though I said 5, that was actually impossible. It was actually -5. Good job. -5. Do I want a bracket or parenthesis there?
Bracket.
Good. To what?
Infinity.
Correct. Any questions about domain and range from a picture? Okay, that was the key thing there. Yes, sir.
What's the difference between the brackets and the parentheses?
All right. Because this touches at this spot, any number it touches, then it's got a bracket there. Any number it doesn't touch, like, do you actually touch infinity? No, so they need a parenthesis on things you don't touch. So I'm going to give you a more complicated example with the bracket and the parenthesis. So imagine you have a function that does this. First of all, does that pass the vertical line test?
No.
Yes, it does, because you could draw a vertical line everywhere and it only has, like, it only touches once. So that is a function. Now let's say this spot at the very end here is important for the domain and the range. So let's say it's -3, -2. That tells you how far left and how far down it went. This spot over here is empty, and that means we don't touch this spot, but it would have been 12, 5. So that's kind of weird, right? Because it gets really close to that spot, but it doesn't actually touch that spot. That means your range on this will have one bracket and one parenthesis. Your domain will too. Everybody try to figure out the domain, which is left and right, and range, which is down to up. I'll pause for a second while you guys try that. So, random person, this is row 1, third person. Max, what do you say the domain is?
Domain would be -3 and 12.
-3 to 12 is correct. Good. And which one has a bracket? Which one has a parenthesis?
That's a trick question. They both have brackets.
Pretty sure it doesn't touch 12. So therefore, parenthesis there. Bracket, then parenthesis. I think that's how it works.
Is that because there's a dot that doesn't have in the middle?
Yep, because that is very specifically an empty circle versus a filled in circle. It's a lot like the greater than or equal, that's like an or equal there, compared to a just greater than. And you know how there's solid lines and dotted lines and that other thing? It's like that. Okay, now how about the range? Random person, row 1, person 1. That only happens 6 times 6 is 1 in 6 chance, 1 in 6 chance, 1 in 36 chance that you get called on. So, what was the range? -2 is the lowest it went. Good. Does it touch that or not? Bracket. 2, 5. And parenthesis or bracket? Parenthesis. Raise your hand if you had that one right. Okay, cool. You getting domain and range? Because the only new thing now for today is we just practice this more, but we add in that the functions will move. You know, all in the past, whenever I did the parabola, it was always right here. And it goes through 0, 0 and stuff. But what if I want to make it move? Well, this is how this works. you start with your parabola, which is y equals x squared, but then I'm leaving a lot of room by that, because if I go like this, you want notes on this, everybody, write this down. That would mean right 8. That will move it to the right 8. Now that should feel wrong to you. Minus the negative numbers are this way, Mr. Server. That seems like it should move to the left. But do you remember this rule about things on the inside being opposite of what you would think? Maybe you have never heard that before. Maybe I'm the first to teach you that. But stuff on the inside of your function will always do the opposite of what you would think it will do. It's true. It's kind of like counterintuitive. Apple is really good at making things that are intuitive. Like my dad, who was really old, when we got him his first iPod Touch, which is a lot like a phone that just isn't connected up to the internet. But his iPod Touch, he had no idea how to do technology. Remember, he was born back in the days when they didn't even have like flush toilets. Okay, so for him, this was the first, it was even before iPhones came out. This was the first technology he ever really had, other than like in his hand, like you guys all are so used to. But he could operate it just fine because they made it so easy. You just touch the thing you want to open, and then you touch the things to, like, he learned how to play solitaire all by himself, just dragging the cards around and stuff. It was easy for him. It was called intuitive. And Apple's really good at making things that are just kind of intuitive. You know kind of where to click and what to touch to make it open and do things. But if something is not intuitive, that's called counterintuitive. Okay, so like one of those things that's counterintuitive. Did you know that if you work out more, you might actually get weaker? It's true. Do you get some kids that are like, oh, working out is good. I'm going to work out every single day. And they actually burn their muscles down so bad that they actually get weaker and weaker and weaker because they're never giving themselves the chance to recover. Okay, so the latest research is working out a couple times a week or maybe 3 times a week is the most you should do. Otherwise, your muscles don't have time to recover. So kind of counterintuitive. You would think if I work out more, I'll get stronger. But if you work out like 4 hours a day, every single day, your body isn't recovering enough and it actually won't work very well. Now, you can get around that by only working a certain muscle. Like you're really careful to only work your biceps on Tuesdays and you work your legs on Thursday or Wednesdays. You can get around that. But my point is, some things are counterintuitive. You wouldn't think that's true. There's a lot of things in life that are kind of counterintuitive. And you wouldn't expect this, but it's actually true. Okay, so get used to that because everything on the inside does the opposite of what you would think. -8 is over here, but we're not going there. It would go to the right. Okay? On the outside, you can trust it. So if I put a +7, it seems like you want me to move it up 7, and it is up 7. So on the outside, it controls the up or down. And if it's positive, that seems like up, and it is up. So bottom line, things that are on the outside, you can trust. Things that are on the inside, you can't trust. Yes?
So if it was a positive on the inside, it would be black?
Correct. And if it was negative on the outside, then that would mean, it would seem, negative seems like down, and it is down. So you can intuit what's on the outside, like it is intuitive. Stuff on the inside, counterintuitive, like that doesn't seem right. That's what it is. Another way you could say it is it's like opposite day on the inside. Figure out what you think it should be and then do the opposite. Okay, and then the last little thing about these moves that you got to know is that things on the inside are horizontal moves. Like right and left, do you agree that those are horizontal things? Okay, so horizontal on the inside, high. Vertical on the outside, vo. High vo. It's a dumb little saying that we math teachers use, and your next year's teacher will use it too, and they remind you about this, which will be in either FST, which is frankly where most of you probably should go, is FST. That's the normal next class after this. Some of you will choose to step up a lot and take pre-calc, and I'm cool with that. If you're getting A's in here, you should think about taking pre-calc. Think about it, but it's definitely way harder. But anyway, either way, whichever class you're in, this is a big deal. So like what I teach you over the next couple of days, this moving stuff left and right and up and down, it shows up on ACT test, It shows up on Minnesota State Standards tests. It shows up in both classes next year that you might take. Okay, so we really got to learn this. And you might think I say that about everything. I'm trying to really make a point. This is a big deal, more than everything else I teach. It's like one of the number one things. You've got to get this moving left, right, and up, down. Okay, so imagine I gave you this one. First off, you got to know that the absolute value looks a certain way. Can you picture it in your head? If you haven't memorized them yet, you got to get this down. Who was thinking V shape? You were right. That's what the absolute value looks like. So it's a V shape, and now let's say I put a +1 in here, and I put a +4 out here. One of them you can trust, one of them you can't. Which way is that one moving, Jack? Left. And which way is that one moving, EJ? Up. That makes sense to you? Okay, so we're just learning how to move these things left and right and up and down. And one other thing. Do you know if you put a negative in, that means the opposite of? So how the heck can we do the opposite of a shape? Well, anybody want to take a guess what happens to this V shape? Just guess. It flips, yes. But there is two ways to flip something. This is on the outside, so our high VO thing comes in handy. That's a VO. That's a vertical flip. Can you imagine how a vertical flip would go? Do you get it? It would look kind of like that. It would flip upside down that way. Do you get how if I flipped it the other way, it would actually be right on top of itself? That's hard for a lot of kids to envision. But if this V flipped left, right, then this side would go over here and that side would go over there and it'd be right on top of itself. It would like it never even moved. But a vertical flip makes it go down there. Okay, so that is a flip, but there's an official math name for it. It's called a reflection. So that was technically a vertical reflection. Okay, we're almost at lunchtime. See if you can hang in there for another minute here. Imagine I have an upside down parabola that's moved to the left and up. And it's left 3, so it's at -3, 2. If you know that's left and up, and it's x squared, but I got to leave some room in here. If I moved it left 3, seems like I should put a -3 in here. So I don't. I put a +3. Do you get what just happened there? It went left 3, so I had to say +3, even though it seemed like I should put -3 there. And then it went up 2. So I trust that, and I put a +2. But wait, it's also flipped over. Normal parabolas are right side up. You get there's also a negative right there. Because it's flipped upside down from a normal parabola. That's a function that has had 3 what are called transformations. Left 3, up 2, I trust that one. And that is a vertical, because it's on the outside, high VO, a vertical reflect. I think that's enough before lunch. We'll talk about the rest after lunch. We're back from lunch, and what we were doing when we left was things like this. Y equals the square root of x minus 8. Wouldn't you think that moved 8 to the left? Because that's where -8 is. But it actually, I think you know from the way I said it, that that's right 8. What if I put a negative in front of it? Then the square root graph would flip over. But there's 2 ways to flip over. This is a VO. Can anybody tell me what the heck that means? VO. What's the V stand for? Vertical. And the O? On the outside. All right, so this is high, horizontal on the inside, and this is VO, vertical on the outside. Okay, so that's a vertical reflect. This is a horizontal, which you guys all know right and left is horizontal, right? A horizontal move to the right. All right, so if I actually had to graph this thing, what would I do? I'm gonna delete back out a bunch of things here. And now, if I had to graph this, I would make an XY chart like I always do. But I would be very careful about what numbers I just put in. I can't just go 0, 1, 2, because look, as soon as I put in a 0, it's the square root of -8. That doesn't even exist. So I gotta be careful about what I put in. So I'm gonna be like thoughtful. I'm gonna think, what if I put in 9? 9 minus 8 is 1. Can I do the square root of 1? You know what the square root of 1 is? It's 1. 9 comma 1 is one of my points. Now, some people do the parent points and then move them all. It's so much easier to do it this way. You just think, what else could I put in besides 9? Well, 10, if you just do it in your head quick, it won't work nice because you'll have 10 minus 8 is 2 and the square root of 2 doesn't work nice. So you go, okay, scratching 10. Who knows the next one? 11's not going to work nice because it'll be 3.
16.
16. 6. I want it to be 16. You're right. So what do I put in so that it's the square root of 16? Well, I got to think of what could I put in there to make it come out to 16. It'd actually be 24. So that's a really big number to put in, but it would work. And then when I take away the 8, I get 16. And then this 24 minus 8 is 16. And then square root of 16 is 4. I'm going to redraw this and erase this so you can see it better. Okay. So what else could I put in? Hint, square root of 0 isn't illegal. So what should I put in? 8 is correct. Because do you get then square root of 0 is just 0. And I'm finding points, it's just harder. And then all I got to do is graph those points. Watch what happens. I go over 9, up 1. Over 24 and up 4, that one's way off the chart. Over 8 and up 0 is right here. And do you get my ramp that's just moved over there? How far over do you think it moved? Look, it moved over 8. Doesn't that make sense? I mean, it's got the minus 8 there. That means right 8. And look, that's where all my dots are. They moved over this way. Okay, so here's one. Everybody, please write this down. Y equals absolute value of x minus 2. Would you agree that that is a V shape that's been moved? Which way has it been moved? Jack? Close. That's what it seems like it does. So you have to do the opposite of that. Right 2. So it's a V shape moved right 2. But actually, where are the dots? Let's make an XY chart. Jackson, can you undo your hood so I can see you don't have headphones? You don't have headphones. You're good. Okay, so then let's move on. Did you tell me a number I can stick in, Jackson? Hint, it really doesn't matter on this kind. You could put any number you want. 4 sounds good. So we put in a 4, and then we got 4 minus 2 is 2, and absolute value of 2 is 2. So 4 comma 2 is on my graph. If you make enough dots, then you will find it. Okay, so Ian, could you shut the blinds because you're just distracted by whatever's out there. Thank you. Okay, so now would you give me another number? This is the easiest thing I can ask you. Pick a number.
7.
Okay, now we're going to put in 7. Now help me with this part. It's a little harder, but not that bad. Put in the 7 right there, and what do I get on the inside?
5.
Yep, so then the absolute value of 5, which is
5.
5. Then 7 comma 5 is on my graph. And do you get, if I make enough dots, I'll get a V shape that's been moved right 2. If I actually graph this, it's going to be like this. And those dots, like 7 comma 5, it's like there-ish. And 4 comma 2, it's like there-ish. And if I put in 0, I'd also get 2. Over 0 up 2, that's there. And if I put in 2, I'd get 0. See how all the dots are just showing up right on my graph? Okay, so what's the moral of the story, Mr. Server? You got to know how to move stuff. And it's always the opposite of what you think on the inside. And that's the horizontal on the inside. If it's on the outside, it's vertical. Vo on the outside. And you got to know how to make points again. And then that's it. You're ready. So let's start the homework. Everybody find the homework that was assigned for today. I believe. Actually, I'm not positive. You tell me. What? There's nothing there? Okay, I'm going to pause for a second. Okay, so we have a super easy, super short Schoology quiz. And that'll be obvious when you find the November 8th folder. And then we have another thing called U5L3, which is tomorrow's worksheet, but I'm just getting started on it today. So I know you're all going to finish that Schoology quiz in like 5 minutes. So let's not have a super easy day today and then like a really hard day tomorrow. Let's just start tomorrow's today. So here's the beginning of that worksheet, 1A. It asks you to take this and translate it down 3. Translate just means move. Down 3. Well, that's not that hard. You go x squared, but then to move it down, is that on the inside or the outside? Is down like a horizontal thing or a vertical thing? Vertical. And so vertical is on the outside. So this down 3 should be on the outside. There. That means down 3. That's it. That's 1A. So if you're not done with the other thing yet, I'm going to leave these up on the board for a minute or two. I encourage you to go get the first couple answers for free here. Y equals the square root of x is up 4. Well, then I just go like this. Y equals square root of x. And how do I do up 4? That's on the outside. And I go up 4. Notice I didn't put it on the inside because that's for left or right. Stuff on the outside is up and down. Okay, so there's the start of the worksheet. If you get stuck, please come up and ask. Tomorrow you'll have a bunch of time to work. I'll ask to see your worksheet that you're working on it. So just try to get started today. And then tomorrow we'll get serious about finishing that worksheet and understanding left, right, up, down, and how to graph these things, because that's the second part of the worksheet. And that's all I got for the video for today.